Hello, in this lecture we'll answer two questions. On both questions we find out the area of a trapezoid. So what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD. This trapezoid ABCD, side AB is parallel to the opposite side DC. Those two parallel sides are defined as the basis of this trapezoid ABCD. So side A, the base AB is parallel to the opposite side DC, and the area of this trapezoid ABCD is equal to the sum of its two parallel bases times the height over 2. If we define the length of side AB as B and the length of side DC as A, then the area of this trapezoid ABCD will be equal to A plus B, that is the sum of its two parallel bases, times the height, that is H over 2. The height H must create 90 degrees with the two parallel bases. So a trapezoid is a quadrilateral with one pair of parallel sides, and the area of a trapezoid is equal to the sum of its two parallel bases times the height over 2. In this case, the area of this trapezoid ABCD is equal to A plus B times the height H over 2. So in the first question, we have been given a trapezoid ABCD. We know that the perimeter of this trapezoid ABCD is 16 units. That is to say, the sum of the lengths of all the sides of this trapezoid ABCD is 16. That is to say, AB plus AD plus DC plus CB in total is equal to 16 units. That is actually the perimeter of this trapezoid ABCD. In addition, we know that side AB of this trapezoid ABCD equals to 2 units, and we also know that side BC equals to side CD. Again, our mission is to find out the area of this trapezoid ABCD. Those two angles are defined as right angles, and our mission is to find out the area of this trapezoid ABCD. Okay, so we know that the perimeter of this trapezoid ABCD is 16. That is to say, AB plus AD plus DC plus CB in total is equal to 16 units. So I write it down. Again, the perimeter of a trapezoid is the sum of the lengths of all the sides of trapezoid ABCD. That is to say, it is AB plus AD plus DC plus BC is equal to 16 units. We define the length of side AD as A. We define the length of side DC as B. And because of the fact that DC equals to BC and DC equals to B, therefore BC must also equal to B. AB is 2, therefore we substitute AB by 2 plus AD. AD is A according to our definition, so we substitute AD by A plus DC. DC is B plus BC. BC is also B, and it is equal to 16. So in total, we should find out that 2 plus A plus B plus B equals to 16. Here we subtract 2 from this equation, I get that a plus b is a plus 2b, and it is equals to 16 minus 2, that is 14. So a plus 2b equals to 14. Here we subtract 2b from this equation, and get that a equals to 14 plus 2b. So AD equals to A units in itself, and A equals to 14 plus 2b. In the next step, we will do a construction. This is to say from the vertex B of this trapezoid ABCD, we draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to our construction. And we find the touching point of the perpendicular from point B and DC. This point is point M. When doing this construction, we can do the corner ABMD. Inside this corner ABMD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees, according to the rule that says that the sum of the angles in any corner is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside corner A, B, and D, we have 4 right angles. And according to rule 5, any corner that has 4 right angles must be at least a rectangle, if not a square. So we relate to this corner A, B, and D, it's a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABMD, side AB equals to the opposite side DM. But AB is 2, therefore DM must be also equal to 2 units in its length. Likewise, according to the same rule, in the same rectangle ABMD, side AD must be equal to the opposite side BM. But AD is 14 minus 2b, therefore the opposite side BM must be also equal to 14 minus 2b units in its length. What is the length of the missing line segment? MC. MC equals to BC, MC equals to DC minus DM. So write it down. MC equals to DC minus DM. So MC equals to DC. DC is B according to our definition. Minus DM. Just right now found out that DM equals to 2. So in total, MC equals to B minus 2 units in its length. In the next step, I'll copy the right triangle BMC in a new page and implement the Pythagoras theorem in this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, this is the right triangle BMC that the co-triangle you're drawing. In this right triangle BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. So I write it down. BC squared, that is the square of the hypotenuse, is equal to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, we should find out that B squared equals to 14 minus 2B squared plus B minus 2 squared. So here we open the brackets on this side of this equation and we get that B squared equals to 14 squared minus 2B squared. 14 squared minus 2B squared equals to 14 squared, that is 196, plus 2B squared, that is 4B squared, minus 2 times 14, that is minus 28 times 2B. Minus 28 times 2B is minus 56B. And we have also plus B minus 2 squared. B minus 2 squared equals to B squared plus 2 squared, that is 4. Minus 2 times B times 2, that is minus 4B. So here we have B squared on both sides of the equation, so B squared gets cancelled. So we cancel B squared. In this side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have 196 plus 4, that is 200. We have minus 56B minus 4B is minus 60B. And we have plus 4B squared. So in total, we should find out that zero equals to 200 on 60b plus 4b squared. So here we divide this equation by 4 and you get that 4b squared over 4 is b squared, and we have minus 60b over 4 is minus 15b, and we also 200 over 4 is 50. And it is equals to 0 over 4 is 0. So in total we should find out that b squared minus 15b plus 50 equals to 0. So this is a quadratic equation. And then the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, capital A, capital B, and capital C are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared plus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is small b, so x equals to small b. This is the variable that we are looking for in our specific quadratic equation. the coefficient capital A equals to 1, the coefficient capital B equals to 2, the coefficient capital B equals to minus 15, the coefficient capital B is equals to minus 15, while the variable that we are looking for is small b. So x equals to small b and the coefficient capital B equals to minus 15. And the coefficient C equals to 50. So the only thing that is left to do is to put this data in our specific, in this general formula for x. In this way we find out the value of the values of small b because x equals to b. So we do it now, we get that x equals to small b, so we substitute x by small b and it equals to minus capital B. Capital B equals to, that is the coefficient of this specific quadratic equation. Capital B equals to minus 15, therefore minus capital B is minus 15, that is plus 15. Plus minus square root of capital B squared. Capital B equals to minus 15, therefore capital B squared is minus 15 squared, that is 225. Minus 4 times A. A is 1, so minus 4 times 1 is minus 4 times C. C is 50, so minus 4 times 50 is minus 200. So inside the root we have 225 minus 200. All divided by 2A. A is 1, so 2A is 2 times 1, that is 2. So in total, if we found out that small b, that is the variable that we are looking for, is equal to minus 15 plus minus, inside the root we have 225 minus 200 is 25 and the square root of 25 is 5 divided by 2. So here we have two solutions that are possible for b. We define the first solution is b1 and the second solution is b2. So the first solution for b, that is b1, is equal to 15 plus 5 over 2. 15 plus 5 is 20 and 20 over 2 is 10. So the first solution for b is b1, that equals to 10 units. And the second solution for b will be actually b2. And b2 equals to 15 plus 5 over 2. 15 minus 5 is 10 and 10 over 2 is 5. So the second solution for b is b2, this equals to 5. AD is one side of trapezoid ABCD. I know that the length of side AD is A and A equals to 14 plus 2B. So AD is equal to A units in its length and this also equals to 14 minus 2B. So AD is a length, and as a length it must be a positive number. That is to say, it must be greater than 0. And from this long equation, we derive that 14 minus 2b is greater than 0. 14 minus 2b is the expression for the length of side AD, and the length is a positive number, that is to say it must be greater than 0. Here we add 2b to this inequality, and we get that 14 is greater than 2b. So here we divide this inequality by 2, and we get that 14 over 2 is 7, and 7 is greater than 2b over 2 is b. So in total, if you found out that b is less than 7 units. So b, that is the variable that we are looking for, must be less than 7 units from one side. But from the other side, according to the first solution for b, b is equal to 10. That is greater than 7. So here a contradiction, b must be less than 7 units, but according to the first solution, b is greater than 7. Therefore, the first solution is a correct solution. We cancel the first solution, and we left only with the second solution for b. This is actually b is equal to 5. So b equals to 5, dc equals to b, and b equals to 5, so dc equals to 5, dc equals to 5, ab equals to 2, and ad equals to a, and a equals to 14 plus 2b. b is 5, so minus 2b is minus 2 times 5, that is minus 10, and 14 minus 10 is 4, so a equals 14 minus 10 is 4. So AD is equals to A is equals to 4 units in itself. Our mission is to find out the area of this trapezoid ABCD. According to the formula that I presented to you in the beginning of the lecture, the area of trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually AB plus DC, times the height. The height is AD. Why the height is AD? Because of the fact that the height AD creates 90 degrees with the base AB, and the height AD also creates 90 degrees with the base DC. So the height is AD, so it is times AD, the height AD over 2. So in total, if you found out that the area of trapezoid ABCD, this is the area that we are looking for this question, is equal to the sum of its two parallel bases. This is actually AB plus DC times the height AD over 2. AB equals to 2 according to what is given as the question, plus DC. DC equals to 5 because it's B. It is B that is equals to 5. So DC is 5. So we let 5 here times AD. We already found out that AD equals to 4. AD, that is the height of this trapezoid ABCD, is equals to 4 units in its length. So we substitute AD by 4 divided by 2. 2 plus 5 is 7, and then 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14 square units. So if I found out that the area of trapezoid ABCD, that is the area that we are looking for this question, is equal to 14 square units. Again, if I found out that the area of this trapezoid ABCD is equal to 14 square units. So I finish with the first question. In the next step, I present to you the second question, and we will solve the second question of this lecture. Actually, in the second question, we have to find out the area of another trapezoid. The name of the trapezoid is ABCD. It is the same name as in the first question, but the trapezoid is different trapezoid. So, in the moment we have trapezoid ABCD, and we have to find out the area of this trapezoid ABCD. We know that the length of side AD is 2x, side BC equals to x units in its length, line segment BM equals to 2 units in its length, line segment AM equals to 3 units. Those two angles are right angles, and this is angle A and B. This is also a right angle. Again, our mission is to find out the area of this trapezoid ABCD. This is totally different trapezoid than that we had in the first question. So first of all, we define the size of this angle BMC as alpha. So in the right small triangle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in an triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line DC at point M here, the sum of the angles must be equal to 180 degrees. According to rule 3, that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, plus this angle that is 90 degrees, plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line DC at point M, exactly according to rule 3. So this missing angle must be equal to 90 degrees minus alpha. In the right big triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in an triangle. In the next step, we focus on those two right triangles. That is to say, we focus on the big right triangle ADM, and we focus on this small right triangle BCM. So, those two angles they are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So if you prove that all the triangles of this right big triangle ADM are correspondingly equal to all the triangles of this right small triangle BCM, and therefore those two right triangles are similar to each other according to angle similar to rule. So I have it down. If you prove that the right triangle ADM is similar, this is the sum of similar to the right front triangle BCM, according to angle similar to rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AD of this big right angle ADM over side MC of this small right angle BCM is equal to side DM of this big right angle ADM over side BC of this small right angle BCM. And it is also equals to side AM of the big right angle AMD over side BM of the small right angle BCM. So repeat again. We will derive the side AD of the big right angle ADM over side MC of the small right angle BCM equals to side DM of the big right angle ADM over side BC of the small right angle BCM, and it is also equals to side AM of the big right angle ADM over side BM of the small right angle BCM. AD equals to 2x over MC. MC is the missing side, so we limit as it is. And it is equals to side DM. DM is the missing side, so limit as it is. Over side BC. BC is x. And it is also equals to side AM, that is 3 units, or side BM, that is 2 units. So in total, if you found out that 2x over MC equals to dm over x, and it is also equals to 3 halves. Those two expressions are equal to each other, therefore we get equation 1 from those two expressions that are equal to each other. According to equation 1, 2x over MC equals to 3 halves. So write it down. So according to equation 1, 2x over MC equals to 3 halves. Here we multiply this equation by MC, and you get that 2x equals to 3 halves times MC. So here we multiply this equation by 2, and then we divide it by 3 simultaneously, and we get that according to equation 1, MC equals to 2 times 2x over 3. So MC equals to 2 times 2x is 4x over 3. So in total, if you found out that MC equals to 4x over 3. This is side MC, this is equals to 4x over 3 is in its name. those two expressions are also equal to each other. Therefore, we get equation 2 from those two expressions that are equal to each other. So according to equation 2, we actually get that dm over x equals to 3 halves. This again, according to equation 2, dm over x equals to 3 halves. Here we multiply this equation 2 by x, and we get that dm equals to 3 halves times x. So actually this is side dm is equals to 3x over 2 units in its length. We can say that also dm equals to 3 halves times x units in its length. In the next step, I'll copy this right small triangle MVC in the project. We'll implement the Pythagoras theorem on this right small triangle MVC. The hypotenuse BM equals to 2 units in its length. BC equals to x units in its length according to what is given as the equation. And we just write down further that times side MC of the right triangle BMC equals to 4x over 3 units in its length. So here by PT is the version from Pythagoras theorem. So actually, this is the right small triangle BMC to the common from the original drawing. According to the Pythagoras theorem, in this small right triangle BMC, BM squared, that is the square of the hypotenuse, equals to BC squared plus MC squared. So BM squared, that is the square of the hypotenuse, equals to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4. And it is equals to BC squared. BC is x, therefore BC squared is x squared plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So if you follow that 4 equals to x squared plus 4x over 3 squared is 4 squared, that is 16, times x squared over 3 squared, that is 9. So here we multiply x squared by 9 and then we divide it by 9 in order to have a common factor with this expression. So we get that 4 equals to 9x squared over 9 plus 16x squared over 9. 9x squared plus 16x squared is 25x squared over 9. So in total we can find out that 4 equals to 25x squared over 9. And again, I can find out that 4 equals to 25x squared over 9. So here we multiply this equation by 9 and we get that 25x squared equals to 9 times 4 is 36. So here we divide this equation by 25 and we get that x squared equals to 36 over 25. So here we take a root out of this equation and finally we get that x equals to the square root of 36 is 6 over the square root of 25 is 5. So in total we can find out that x equals to 6/5 units in itself. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? According to the formula that I presented to you at the beginning of the lecture, the area of trapezoid ABCD will be equal to the sum of its two parallel bases, that is actually AD plus BC, times the height over 2. The height is DC. This is the height because of the fact that it's 90 degrees with the two parallel bases. So this is the height divided by 2. So in total we should find out that the area of trapezoid ABCD is equal to AD plus BC, that is the sum of its two parallel bases, times the height DC over 2. AD is 2x plus BC is x, times DC. DC in total equals to 3x over 2 plus 4x over 3. Okay, so we can find out that the area of trapezoid ABCD equals to 2x plus x, that is 3x, here we have to divide everything by 2, of course. And we have inside the brackets here 2 x over 3 plus 4x. It is actually 3x over 2 plus 4x over 3. So here we take 6, we take out 6 as a common factor from those two expressions. That is to say, we multiply both the numerator and the denominator of this number, of this expression 3x over 2 by 3. So 3x times 3 is 9x over 2 times 3 is 6. Likewise, we multiply both the numerator and the denominator of this expression 4x over 3 by 2. 4x times 2 is 8x. And we have 3 times 2 is 6. We have to divide everything by 2. So in total, the area of tablet ABCD is equal to 3x over 2 times 6. And we have here 9x plus 8x is 17x. So in total, the area of tablet ABCD equals to 3x times 17x over 2 times 6. So here we divide both the numerator and the denominator of this expression by 3, and we get that 3x over 3 is x. So in total, in the numerator we have x times 17x, and we have to divide the denominator also by 3. 6 over 3 is 2, so in total, in the denominator we have 2 times 2. 2 times 2 is 4. So in total, we get that the area of the ABCD is equal to 17 times x over 4. We already found out that x equals to 6/5, therefore we substitute x here by 6/5. And we get that the area of the ABCD equals to 17 over 4 times x. X is 6/5, so we substitute x by 6/5, and we have x again, so we substitute x again by 6/5. So in total, the area of tablet ABCD equals to this expression. So we have 6 times 6 is 36, and 36 over 4 is 9. So we substitute those three numbers by 9, because now in total equals to 9. And we left only with 17 over 5 times 5, that is 25. And here we substitute those three numbers by 9. So in total, the area of tablet ABCD equals to 17 times 9, that is 153 over 25 square units. So in terms of numbers, it is equal to 6.12 square units. So if it again, if you found out that the area of this tablet ABCD is equal to either 153 over 25 square units, or in terms of numbers, it is equal to 6.12 square units. So we finish with the second question. So in the next step, I'll summarize the lecture. We'll start with the first question, of course. So, first of all, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD, trapezoid ABCD is a quadrilateral because trapezoid ABCD has 4 sides, and this quadrilateral ABCD, side AB is parallel to the opposite side DC. Therefore, this quadrilateral ABCD is defined as a trapezoid. In this trapezoid ABCD, side AB is parallel to the opposite side DC. So those two parallel sides are defined as the bases of this trapezoid ABCD. So if we define the length of AB as B and the length of DC as A, then the area of this trapezoid ABCD will be equal to A plus B, that is the sum of its two parallel bases times the height edge over 2. The height edge must create 90 degrees with the two parallel bases. So a trapezoid is a quadrilateral with one pair of parallel sides, and the area of the trapezoid is equal to the sum of its two parallel bases, that is actually A plus B, times the height edge over 2. Again, the height edge must create 90 degrees with the two parallel bases. So let's start with the first question. In the drawing, we have trapezoid ABCD. We know that the perimeter of this trapezoid ABCD is equal to 16. So what is the perimeter of a trapezoid? The perimeter of a trapezoid is the sum of the lengths of all the sides of the trapezoid. Okay, the sum of perimeter of trapezoid is defined as the sum of the lengths of all the sides of the trapezoid. In our trapezoid ABCD, the perimeter is 16. That is to say, side AB plus side AD plus side DC plus side CB total are equal to 16 units. Okay, again, the perimeter of this trapezoid ABCD is 16. That is to say, side AB plus side AD plus side DC plus side BC equals to 16. We know that AB is 2. We define side AD as A. We define side DC as B. Because of the fact that DC equals to BC, DC also will be equal to B. So in total, the perimeter of this trapezoid ABCD will be equal to 2 plus A plus B plus B. Again, AB is 2, AD is A, DC is B, and BC is B. Also, so in total, the perimeter of trapezoid ABCD will be equal to 2 plus A plus B plus B. That is 16, according to what is given as the question. We subtract 2 from this equation. I found out that 16 minus 2 is 14. So in this side of the equation, we have A plus B plus B, that is A plus 2B. So A plus 2B equals to 14. We subtract 2B from this equation, and find out that A equals to 14 minus 2B. So here, the side AD is equals to A unit in itself, it is equals to 14 minus 2B. In the next step, we did the construction, that is to say, from this vertex B of this trapezoid ABCD, we go perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point M. When doing this construction, we can do the quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees, so 270 degrees plus the size of this 4 pieces again. In total, it must be equal to 360 degrees according to the rule that said that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4 pieces again must be equal to 90 degrees in its size. So inside quadrilateral A, B, and D, we have 4 angles, and according to rule 5, any quadrilateral that has 4 angles must be at least a rectangle, if not a square. So relate to this quadrilateral A, B, and D is a rectangle because it has 4 angles. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle A, B, and D, side A, B must be equal to the opposite side B, M. but AB is 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B units in its length. Likewise, according to the sum rule, in the sum rectangle AB MD, side AB must be equal to the opposite side DM, but AB is 2, therefore the opposite side DM must be also equal to 2 units in its length. What is the length of this missing line segment MC? MC equals to DC minus DM. Again, MC equals to DC minus DM. So MC equals to DC, that is B, minus DM, that is 2. So in total, MC equals to B minus 2 units in its length. In the next step, according this right triangle VMC in the new page, we implemented the Pythagoras theorem in this right triangle VMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. Okay, this is the right triangle VMC that is coming from the original drawing. According to the Pythagoras theorem, this right triangle VMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it equals to BM squared. BM is 14 minus B, therefore BM squared is 14 minus 2B squared. And we also plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, we should find out that B squared equals to 14 minus 2B squared plus B minus 2 squared. We open the brackets on this side of this equation and find out that B squared equals to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared, that is 4B squared, minus 2 times 14, that is minus 28 times 2B. Minus 28 times 2B is minus 56B, and we have also plus B minus 2 squared. B minus 2 squared equals to B squared, plus 2 squared, that is 4, minus 2 times B times 2, that is minus 4B. So here we have B squared on both sides of this equation, so B squared gets cancelled. After cancelled B squared on this side of the equation, we left with nothing, that is to say 0. While on the other side of the equation, we have 196 plus 4, that is 200. And we also minus 56B minus 4B is minus 60B, and we have also 4B squared. So in total, if you found out that zero equals to 200 minus 60B plus 4B squared. Here we divided this equation by 4 and found out that 4B squared over 4 is B squared. And we have minus 60B over 4 is minus 15B, and 200 over 4 is 50. So in total, and 0 over 4 is 0. So in total, we found out that B squared minus 15B plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, capital A, capital B, and capital C are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, the variable that we are looking for is small b, and the coefficient a equals to 1, the coefficient it is capital B, the coefficient capital B equals to minus 15, and finally the coefficient capital C equals to 50. So the only thing that is left to do is to put this data inside this general formula for x, and in this way we find out the value of the values of b, because x equals to b. So we did it, actually found out that x equals to b, so we substitute x by b, and it is equals to minus capital B, minus b, capital B equals to minus 15, therefore minus capital B equals to minus minus 15, it is plus 15, plus minus square root of b squared minus 4 times AC. So b is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a times c. So it is minus 4 times A is 1, so 1 4 times 1 is 1 4 times C is 50. So 1 4 times 50 is 200 over 2A. A is 1, so 2A is 2 times 1, that is 2. So in total, if you found out that B equals to 15 plus minus, and 225 minus 200 is 25, and the scope of 25 is 5. So in total, if you found out that B equals to 15, B equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for B. We define the first solution as B1 and the second solution as B2. According to the first solution for B, that is B1. B1 equals to 15 plus 5 over 2. 15 plus 5 is 20 and 20 over 2 is 10. So the second solution, the first solution for B is B1, that is 10. And we have also another solution, that is the second solution. The second solution for B is B2 equals to 15 minus 5 over 2. 15 minus 5 is 10 and 10 over 2 is 5. So the second solution for B is B2 that equals to 5. Here AD is one side of trapezoid ABCD, and the length of AD is A, and A equals to 14 as to B. And again, AD equals to A units in its length, and A equals to 14 as to B. 14 as to B is the expression for the length of AD. So AD is a length, must be a positive number. What is a positive number? It is a number that greater than 0. And from this equation, we derive that 14 as to B is greater than 0. So the expression for the length must be a positive number, that is to say, it must be greater than 0. We add 2b to this inequality and find out that 14 is greater than 2b. Here we divided this inequality by 2 and find out that 14 as 2 is 7, and 7 is greater than 2b or 2 is b. So total, if you found out that b is less than 7 units from one side, but from the other side, according to the first solution for b is 10, that is greater than 7. But b must be less than 7. Due to the contradiction here, we cancel the solution. So the first solution, b equals to 10, is the correct solution. So left only with the second solution that is possible for b. That is b2, that is equals to 5. Here bc equals to b and b equals to 5. We know that ab equals to 2 and ad is equals to a, and a equals to 14 minus 2b. b is 5, so minus 2 times 5 is minus 10, and 14 minus 10 is 4. So ad is equals to 8 and a equals to 4. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, the area of trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually AB plus DC times the height AD over 2. Okay, again, the area of this trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually AB plus DC times the height AD over 2. AB is 2 and DC is 5 times AD. AD is 4, so this times 4 over 2. 2 plus 5 is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So if we found out that the area of this trapezoid ABCD is equal to 14 square units. We finish with the first question. In the next step, I presented you the second question, and we solve the second question of this lecture. In the second question, we have to find out the area of another trapezoid with the same name. It's also trapezoid ABCD, but it is a different trapezoid. So, in the drawing, we have trapezoid ABCD. Side AD equals to 2x units in itself, side BC equals to x units in itself. This is line 7 AM, this equals to 3 units. Line 7 PM equals to 2 units in itself. Those two angles are right angles, and this is again A and B, that is also a right angle. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, we define the size of this angle BMC as alpha. So in the right small triangle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this first angle must be equal to 90 degrees round alpha. 1 plus 90 degrees round alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. We know that DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line DC at point M here, the sum of the angles must be equal to 180 degrees according to rule 3, that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha plus this angle that is right angle plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Therefore, this first missing angle must be equal to 90 degrees round alpha. 1 plus 90 degrees round alpha plus alpha is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So this missing angle must be equal to 90 degrees round alpha according to rule 3. So in the big right triangle ADM, this angle equals to 90 degrees round alpha, this angle equals to 90 degrees. Therefore, this first missing angle must be equal to alpha. 1 plus alpha plus 90 degrees round alpha is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees. This is the sum of the angles in any triangle. In the next step, focus on those two right triangles, that is to say, on the right big triangle ADM, and on this right small triangle BCM. On those two right triangles, we have those two angles that are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees round alpha, therefore they are equal to each other. So if you prove that all the triangles of this right triangle ADM are correspondingly equal to all the triangles of this right triangle BCM, and therefore those two right triangles are similar to each other according to angle similar to. So again, if you follow that the right big triangle ADM is similar, this is the side of similar to the right small triangle BCM according to angle similar to. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AD of this big right triangle ADM or side MC of this small right triangle BCM is equal to side DM of this big right triangle ADM over side BC of this right small triangle BCM, and this also equals to side AM of the big right triangle ADM over side BM of this small right triangle BCM. Okay, again, we derive that AD over MC equals to DM over BC equals to AM over BM. AD is 2x over MC. MC is the missing side, so we leave it as it is, and it is equals to DM. DM is also the missing side, so we leave it as it is, over BC. BC is x, and it is equals to AM, that is 3, over BM, that is 2. So in total, we shall find out that 2x over MC equals to DM over x equals to 3 halves. Those two expressions are equal to each other, therefore we get the equation 1 from those two expressions that are equal to each other. So according to equation 1, 2x over MC equals to 3 halves. Again, 2x over MC equals to 3 halves. Here we multiply this equation by MC and finally find out that 2x equals to 3 halves times MC. Here we multiply this equation by 2 and then we divide it simultaneously by 3 and finally find out that MC equals to 2 times 2x over 3. 2 times 2x is 4x, and total this expression equals to 4x over 3. So MC equals to 4x over 3 units in itself. This is MC, this equals to 4x over 3 units in itself. those two expressions are also equal to each other, therefore we can get equation 2 from those two expressions that are equal to each other. So according to equation 2, we should find out that dm of x equals to 3/2. Repeat again, according to equation 2, dm over x equals to 3/2. Here we multiply this equation 2 by x, and finally found out that dm equals to 3/2 times x. So this is line 7 dm, that is equals to 3x over 2, or 3/2 times x. In the next step, I copied this right small triangle BCM in a new page and implemented the parabola form on this right small triangle BCM. Okay, this is the right small triangle BCM that I copied from the original drawing. According to the parabola form, in this right small triangle BCM, Vm squared, that is the square of the hypotenuse, equals to Vc squared plus Mc squared. Bm is 2, therefore Bm squared is 2 squared, that is 4, and it equals to Bc squared. Bc is x, therefore Bc squared is x squared, plus Mc squared. Mc is 4x over 3, therefore Mc squared is 4x over 3 squared. So in total, we should find out that 4 equals to x squared, plus 4x over 3 squared. So 4 equals to x squared, plus 4x over 3 squared. 4x over 3 squared is 4 squared, that is 600 squared, over 3 squared, that is 9. So in total, we found out that 4 equals to x squared plus 16x squared over 9. Here we multiply this x squared by 9, and then we divide it by 9 in order to overcome factor with this expression. And finally found out that 4 equals to 9x squared over 9 plus 16x squared over 9. 9x squared plus 16x squared is 25x squared, 25x squared. So in total, we found out that 4 equals to 25x squared over 9. Once again, so found out in total that 4 equals to 25x squared over 9. If we multiply this equation by 9, and finally found out that 25x squared equals to 4 times 9 is 36. Here we divided this equation by 25, and finally found out that x squared equals to 36 over 25. Here we took root out of this equation, and finally found out that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total, x equals to 6/5. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? It equals to the sum of its two parallel bases, that is actually AD plus BC, times the IDC over 2. So again, the area of trapezoid ABCD is equal to the sum of its two parallel bases, that is AD plus BC, times the IDC over 2. AD is 2x, and BC is x. Yeah, AD is 2x, and BC is x, times DC. DC, in total, it is 3x over 2, plus 4x over 3. And again, dx is 3x over 2, plus 4x over 3, all divided by 2. 2x plus x is 3x. Here we took 6 as a common factor out of those two expressions. That is to say, we multiply this expression by 3 and then we divide it by 3. So here we have 3 times 3x is 9x, or 2 times 3 is 6. Likewise, we multiply this equation by 2 and then we divide it by 2. And 2 times 4x is 8x, and 2 times 3 is 6. So in total, we found out that the area of the ABCD equals to 3x over 2 times 6. Inside the brackets we have 9x plus 8x. So 9x plus 8x is 17x times 3x over 2 times 6. Here we divided both the numerator and the denominator of this expression by 3. And finally found out that 3x over 3 is x. So in total, in the numerator we have x times 17x. In the denominator we have 6 over 3, that is 2. So in total, in the denominator we have 2 times 2, that is 4. So in total, we actually found out that x times 17x over 2 times 2 is the area of trapezoid ABCD. Again, 2 times 2 is 4. So in total, we found out that the area of trapezoid ABCD equals to 16 times x over 4. X is 6/5, so we substitute x by 6/5. So in total, we found out that the area of trapezoid ABCD equals to 17 over 4 times x. X is 6 fifths, x again, that is 6 fifths. So in total, the area of trapezoid ABCD equals to 17 over 4 times 6 fifths times 6 fifths. 6 times 6 is 36, and 36 over 4 is 9. Therefore, we substitute 6 times 6 over 4 by 9. So in total, in the numerator we left only 17 times 9, and in the denominator we have 5 times 5, but 4 was cancelled. So in total, we found out the area of the ABCD equals to 17 times 9 over 4 over 25. 17 times 5 is 153 over 25. So we found out that the area of this trapezoid ABCD equals to either 153 over 25 square units, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. Okay, thank you very much.